Okay, so let's look at the Napier Bones Cipher, which is part of the security challenge, the University Security Challenge. Okay, so this is the basic design. We were lucky enough to take a photograph of a Banksy at GCHQ before it was taken away, and what we have in there is the code embedded into the graphic. So really, the main objective is to embed the graphic into some valid-looking content, and then to be able to easily convert and obviously convert it back again. So as much as possible, it should be as simple to be able to encode and then to be able to decode. So the first thing that really happens is that we just convert the image into base64 format, a fairly standard way of converting binary into a text format. That's then embedded into a program, gchq.exe. It's a .NET program, so anyone analysing it should see the MZ at the start and the standard signs of a .NET program when they're looking at the traces. Then what we do is that we read that into our Cipher program with the -e option, and then that will recreate some GIF file headers and then split the streams into two. So it'll take the exe, split it into two, and then it will compress the stream along with a basic bit flip. So all the bits within each byte inside the compressed stream are just flipped from a 0 to a 1, and we do that, and 1 to 0, we do that with exclusive OR operator. So it's fairly easy to be able to hopefully detect the actual compressed stream, because the cracker just has to try some exclusive ORing from 0 to 255, and then they'll find that the secret exclusive OR value is FF hexadecimal. Okay, so that then produces two GIF files, bullet 1 and bullet 2. We then embed them into our graphic here, and we put the second one there. Okay, so the first one is obviously the key one, because that was the one that will actually have the identification for the GZ compression. After that, we can then run our code again with a -d option, and then that takes the two bullet files together and builds it back up into an exe, out.exe. That then runs, and it will create a hidden file called out.dat, which is the base64 of the PNG, and then we can actually just go straight ahead and actually create our PNG back again. Okay, so that's the basic method of it. What I'll do is I'll show you a run first, and then I'll show you the source code. Okay, so here we are, there's the solution. So we've got two main exes, Cipher and gchq.exe. I won't run the GCHQ program just now, but when it does run, well, I will. Yeah. So let's run GCHQ. It doesn't really produce anything. It doesn't produce any exceptions though. But what we should find is that it actually produces a hidden file here, and inside that hidden file, there's a base64 of the image. Okay, so let's actually just get rid of the file, just so that we can recreate it again. Okay, so before we do that, I'll show you what the crackers will see. Okay, so there's the code, and what they'll see is this. So there are two bullets in here and an HTML file, and these two bullets here are displayed, and these are the ones that will actually contain our Banksy image encapsulated inside the exe. Okay, so our objective is really to create these two files that we integrate into our web page. Okay, so let's go ahead. So if we run Cipher -e, and then we'll give it the name of the program that we want to encapsulate. As simple as that. So we now have two bullet files. So if we actually have a look at them, one is red and the other one is a blue color. Okay, so you would never really be able to tell that those have a hidden program in them which spans across the two files. Okay, so now what we'll do is that we'll run the Cipher, and when we do a -e, it'll take the two bullets and produce a program called out.exe. Okay, so there it's there. So if we run out.exe, that's what we get. But what it's really done is created this little file here. So we'll just open that up, and with inside there, there's some base64. So just let me go to a web page that will allow us to have a look at that base64, just to show that there's no smoke and mirrors here. So I just paste that in. That's the output of our gchq.exe, and hopefully there we go. Okay, so there's the code. There's the code. That's gchq is the answer. Okay, so that's the way that it's actually done. So I'll show you now the code that we've used. So let's have a look here. Oops.